Hello guys, welcome to the channel. Today we will discuss silent score. So what is silent score? Silent score is method used to check how good our clustering is. Means you have like chosen cluster number as 2, 3 for building the model. So it will tell us that you have basically chosen the correct cluster number or not. Okay. All data, it tells us all points correctly placed in their clusters, all clusters clearly separated from each other. And this silent score is used in unsupervised learning algorithms like k-means clustering, hierarchical clustering, DBSCAN clustering. All these three clusterings algorithm we have seen practically in our previous video, right? So understand this. This is very important. Range of silent score -1 to 1. Okay. So the score of choosing the cluster number will always lie between -1 and 1. Now, if your score of choosing the cluster number is close to 1, then it is excellent cluster, means you have chosen the right number of clusters. Okay. But if your cluster numbers score is close to -1, then it is wrong clustering. Okay. You should not choose that number of cluster you have chosen. Okay. And around 0 clusters overlap. Okay. So we will always try to reach to close to +1. Okay. So let's see how we can perform silent score, how we can check we have chosen right number of clusters or not by silent score. Okay. Let's see. So I have already explained k-means clustering. Okay. So what I will do now is I will simply copy paste starting code of k-means till the model building of by k-means clustering. Okay. I will simply copy paste. Then I will perform silent score. K-means clustering and these all clusterings, k-means, hierarchy clustering, DBSCAN, I have already explained practically. Okay. I don't need the plotting. K-means. Okay. Now, so 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 when we were building our model, then we saw by elbow method we got three number of clusters as three. Okay, right? So in that case, when we are building our model using k-means clustering, we have chosen the n number of clusters as three. Okay. Now we have taken the three number of cluster that is right or not, or we can choose different number of cluster which is perfect for our prediction. Okay. Now, so so I think, yeah, I will copy this also. Okay. Now I will check KMN. This is my object where we have called k-means. Okay. I will check labels. Okay. Means the output labels. Now you can see as we have chosen three clusters, then we are getting three different type of categories: 0, 1, and 2. Right? Now let's check we have chosen right number of clusters or not from learn dot metrics import. I will import silent score. Silent. Okay. Now let's check the silent score of this model we have built. Okay. Let's check. Now I will have to give my data and labels as I will give, sorry, I will give labels as my KMN dot labels, right? Now let's check. So we are getting 0.68, which is not very near to plus positive 1. But yeah, although it is saying that this model is also good. Okay. Now let's check. We can choose the different number of cluster, better number of cluster or not by plotting a graph. Let's make a list of Silent score. Here number of clusters I will take 2 to 21. Okay. I will make a list. J for J. I will take in range 2 to 21. I will take. Okay. Now I will give a for loop for I in range 2 to 21. 2 to 21. Let's take km1. I am taking as a variable. Suppose km1. K means I will call. K means, and I will give now n number of clusters as I from 2 to 21. Okay. Clusters as I'm taking as I 2 to 21. Okay. Now I will fit my data into it. Dot fit into data. Okay. Now let's append my Silent score from which I will append Silent score, Silent score data, and I will this time I will take labels of KM1 because I have fitted my data into KM1. So KM1 dot labels. Okay. Now I will append my data. Now let's plot a graph to check if I can take different number of clusters or not. Which number is better for us for taking cluster? 3 or not? We have taken 3 as our cluster. Here 3. Now I am checking if I can take different number of cluster or not. Plt.plot. I will take number of clusters and our SS because SS in SS I have appended the all silent scores from range 2 to 21, right? Now I will give some plt.x label. What should I will give? I will give number of clusters. Number of clusters. Okay. Now on y label, suppose I will give as let's take silent score. Silent score. Okay. And I will give plt dot x as number of cluster. Okay. Now I will give grid so that I can check which value I can take. X is equal to I will take suppose x. Okay. Now plt dot show. Now you can take basically it is saying here you can see it is giving 3. Okay. 3 as the highest silent score, right? It is I got 0.68 as Silent score. This is the maximum Silent score I am getting from the range of 2 to 21. Means I am saying that from 2 to 21, which number of clusters I should take. So it is saying that from 2 to 20, basically, sorry, not 2 to 21, from 2 to 20, 2 to 20, the best number of clusters you can take is 3 because you can check the highest value is on 3 number of clusters in 3, right? You can check around 0.68 and next is on 2, but already I am getting the highest value of Silent score on 3 number of clusters. So it is saying, and it is, I'm checking that it should be close to 1. Okay. So on 3, which is I'm getting around 0.68. So that is the closest point of 1 here in this graph. So it is saying that the best number of cluster you can choose from 2 to 20 is 3 because it is close to 1 with respect to others. Okay, so that's how we can check silent score and the clusters I have taken is correct or not by using silent score. That's how we can check. And yeah, we have chosen the right number of clusters, which I got to know about by plotting this graph. Okay, so that's how we can check total number of clusters we have taken is correct or not by silent score. So that's all in this video. So in the next video, we will see association. Okay. So thank you.